In this video, we are going to see the total internal reflection. We know that light coming from a more dense medium, let's say this is N2 and this is N1. N2 is bigger than N1. If it is perpendicular to the boundary, there will be no refraction. If there is an angle, this angle of incidence, then you see that the refracted ray will bend away from the normal. When you increase the angle of incidence, the angle of refraction also increases. At one point, it doesn't refract but goes back parallel to the boundary of the medium. Here, let's look at the number 3. It comes at such an angle that it doesn't go through the medium 1 but refracted parallel to the boundary. We call this angle of incidence the critical angle. The symbol is C. C is the critical angle. We call it the critical angle is the angle in which the angle of refraction is 90 degree. Here, this is the refracted ray, and the angle between the refracted ray and the normal is 90 degree. If you still increase the angle, this angle is bigger than the critical angle, then you see that the ray doesn't go through the medium 1, it is reflected back its original medium, so this angle should be equal to this angle. This is the situation that we call total internal reflection. This is only occurs when the angle of incidence is bigger than the critical angle. Be careful that this situation is only valid when the light ray coming from a more dense medium to a less dense medium. Let's do an example. The refractive indexes of medium A is given as 2 and B is given as 1.6. Find the critical angle of the rays coming from the medium A to B. Now from the Snell's law, we know that NA times the sine theta should be equal to NB times the sine of angle of refraction, which is equal to 90. So NB times sine 90 degree. Sine 90 is equal to 1. So NA 2 times sine theta is equal to 1.6. So sine theta is equal to 1.6 over 2, 0.8. From the trigonometric values, we know that this angle is equal to 53 degree, but you don't have to know this, just finding this is enough. Now we're going to draw how the light rays KLM travels if the critical angle from glass to air is 40 degree. Now the angle of incidence is 30 degree, which is smaller than the critical angle, so it will go through the other medium, getting away from the normal. Now in the second one, this angle is equal to the critical angle, so it will refract it through the boundary. This angle is bigger than the critical angle, so it will be reflected back, make the total internal reflection with an angle of 50 degree. The illumination of our pools are the examples of total internal reflection. Now look at the diagram. We have a light source at the bottom of a pool. Here we have a light source. Now these are the rays coming from the light source. Now you see that they are getting away from the normal, and this one, it comes with a critical angle and refract from boundary, and the other ones as getting away from the light source, the angle is bigger than the critical angle and reflected back inside the pool. So this area is the illuminated area at the surface of the pool. So what are the factors that affect this illuminated area is, one, the angle of incidence. As the angle of incidence increases, the refraction gets more, so the illuminated area decreases. Think of that the light source is here. So this ray coming to the critical angle point will have an angle bigger than critical angle, so it will be reflected back inside. So the critical angle will be somewhere here, so it will make the illuminated area smaller. The second one, the index of refraction of the medium. As the index of refraction of the medium increases, again the refraction will be more, so the illuminated area will be less. The depth of water, let's say the depth of water is a little less. Let's be here. So you see that this critical angle is equal to this angle. So the illuminated area will be here. So you see, as the depth decreases, the illuminated area decreases, or as the depth increases, the illuminated area increases. We have these three effects that are important in the illuminated area at the surface of a pool. Now let's make an example about this. The illuminated area formed by the light source is A, as in the figure. Which one or ones of the following should be done to increase this area? Increase the index of refraction of the liquid. We said that as the index of refraction of the medium liquid increases, the illuminated area decreases. No. Decrease the index of refraction of the liquid. Yes, as it is less, there will be less refraction, so the illuminated area will increase. Increase the depth of the liquid. Yes, as the depth increases, the illuminated area will also increase. In this example, in both cases, an aquarium is partially filled with water and a layer of oil is floating on top of the water. In the first one, we use oil A. In the second case B, we use the different oil B. And the light rays are coming with the same angles. Now we are going to compare the index of refractions of the oil A and B. Since the angle of incidence are the same, in the first one it is reflected back, but in the second one it can pass through the other medium. That means that an water is more bigger than an A, because here there will be more refraction, and here the light ray can pass through the oil B, and water is bigger than NB, but not as much in case A. So when you get them in one relation, then N water is bigger than NB and it is bigger than NA. So B has a greater index of refraction. Don't forget, as the difference of index of mediums gets bigger, there will be more refraction. Now we are going to compare the index of refractions of the given mediums. Now the light ray coming with an angle of 90, you see no refraction. Here it makes total internal refraction. This angle is 45, the angle of incidence. Coming here, and again it comes with an angle of the same 45 degree and refracted from the boundary of the mediums. Now from X to Z there is total internal reflection, and from Y to Z there is the refraction through boundary. That means that there is more refraction here. As it is more, then the difference between the index of refractions of X and Y is more. So and X is bigger than NZ, and Y is bigger than NZ. So NX is the biggest, then NY, and then NZ. The last question. The light rays pass from medium K to L and K to M is given. So which one from the figure 3 will be the refraction of light from M to L? Now you see that the angles are the same, but here the light ray can pass through the medium L, but this is refracted from the boundary. That means that there is more refraction here, so the K is bigger than M, but K is bigger than L. So NK is biggest than NL, and NM is smallest. So the index of refraction of M is smaller than L. So here the light is coming from a less dense medium to a more dense medium. So it will bend towards the normal. So it will be refracted as 1.